Thank you so much for the kind introduction and a very good afternoon to all of you. It is indeed nice to see that after a post-lunch session also is seeing attendance from quite a few people. So now we have actually over the last 1.5 days, we have seen many different aspects or dots, I would like to call them as dots, of making AI projects or envisaging AI projects or envisaging new innovations. So this is an innovation hat that I would request all of you to wear now so that we can connect those variety of dots, because the sessions were planned so well that the dots are now quite registered in our brains, and now we can easily connect those dots. So as CDAC, we have made quite a few innovations in the area of AI and ML, and I would share some of them with you. These are representative efforts in the direction of productizing AI and solving very simple, specific problems. These are starting points meant to help you think what is your problem and how you will want to address those areas based on the dots that were discussed. I understand very well that it is not easy to connect the dots because like Madam also said yesterday, that we are having multiple presentations on the same topics. And to make a choice is not an easy thing to do. So one of the suggestions which one of the speakers said is, instead of getting scared with so many options that are provided, just start somewhere. So if you start somewhere, you will reach. Definitely you will gain a lot in the process, and based on your discussions with so many experts, I'm sure you will be able to make the right choices as well. So what we will look at are the challenges in oncology. We have looked at a few of them, and specifically what are the challenges for India. IT solutions spectrum. So the spectrum is also very wide. The number of, even within oncology, we have seen since yesterday that the use cases span from oncology itself, cancer itself is so diverse, and the solutions that come along with them naturally will be diverse. Then we will also look at the HPC AI infrastructure, which is one of the important pillars of any AI project, which means some speakers have said that AI is not new, but why is it that it is in use today? So one of the reasons why it is in use now is because the compute power that we have today is huge. And from perspective of doctors, if you want to understand what is supercomputing, it is like you have a laptop in your hand right now. So it's the power of a supercomputer can be imagined like having lakhs of laptops in front of you for processing your AI loads. So we talked a lot about data, but where do we store that data? How do we process that data? How do we analyze that data? How long will it take to do these complex calculations and develop those models? So this platform is the one which enables us to create those models. Then we'll also look at the benefits that this brings, because I was talking to quite a few doctors here, and obviously one of the reasons why we don't venture into AI is we think that it takes too much time, which is true for today, but in the long run, definitely it is going to be a big saver of time. So we need to really understand the importance of spending some time today so that we benefit tomorrow. So it's like doing research in this area, which will help us. Just imagine that in a 12-hour day, even if you make 10% improvement, you are saving 1 hour for yourself. So that can be a very good way to look at, quantitatively look at how do I benefit from doing this AI kind of work. So these challenges we are very much aware, and in an institute like CMC, I think we need not really look at every point, but important aspect in this particular slide perhaps is the need for research-based and evidence-based and precision medicine. So these are some of the keywords which we use, and AI is an enabler for these kind of analysis and research that we are doing. So typically when we have discussions between engineers and medicos, what comes about is we come from very different worlds. So we talk about, let us say, what is the size of your data, how many GB, what is the algorithm, how will it run, which is an efficient algorithm. And then on this side, we observe that you talk about the diseases, about the patient. So the entities which both of us talk about are so different, and we need to kind of create a marriage between the two. And like we have understood since yesterday that there is nothing called, our brain is really complex and we can process so many things at the same time. But that's not true about a computer. So we need to really understand that amongst these 4 buckets, which is the bucket which is going to give me the maximum value. So in terms of screening, very specific questions will be asked by engineers, like what exactly do you want to do? What is the objective of your project? So it's important that we think what is the most important top 1 objective we want to work on. These are the few examples where we have used AI as a pipeline. It is an integrated India-centric oncology platform, and we are focusing more on breast cancer and ovarian cancer in this case. We are working on a variety of data sets, which is on one side radiology, where we look at MRI, we look at CT, we also look at USG data. Then the second side, we also look at pathology. And on the third side, we look at the clinical data, where we create deep learning as well as machine learning based models. So these are some of the components, and I also overheard a conversation just a few minutes back saying that the data is lying in silos. So that is one of the very important first starting points, is to get together that data. And the interesting discussion today morning about federated was equally important, because that helps us to not really move data from one point to another, because simply moving data from one server to another itself becomes a challenge when we talk about big data. So this particular platform actually has web-based screening and case recording system, as well as AI pipelines with MLDL models. So when we talk about web-based screening and case recording system, one point yesterday which came about is, what is the point just creating models and not making them available to the doctors? So this is an effort which helps us to plug in the models that we are creating in the usual workflow of collection of data, where the patient data is being entered, and at the same time there are pop-ups saying that, okay, since you have entered this data, you are able to get these models, and this is the assistance that you will be able to get. So feature-wise, it is a role-based access control-based for doctors as well as AI experts. And like we discussed before, AI and ML models are provided for ovarian and breast cancers. This project has been done in collaboration with AIIMS New Delhi, and we have a couple of publications in this area. Then the other use case we talk about is molecular modeling and drug design. Just the session prior to lunch talked about bioinformatics, and this pipeline, like we also discussed in yesterday's presentation, 2 specific supercomputers have been developed to help us only specifically with bioinformatics workloads. So these workloads are very different from the other AI workloads that we discussed a few slides earlier related to the oncology platform. So here we are using this bioinformatics platform for protein folding, misfolding, for Alzheimer's disease, for cancer protein analysis, for antisense studies, and very importantly in the COVID times for drug repurposing, because it was important that we bring out new drugs quickly. Then genome sequence analysis also helps us to do precision public medicine, breast cancer biomarkers for identification using multi-omics data. So in the in the session before lunch, we had a picture, if you recall, which showed a pipeline of variety of omics data. So what do we do with it? So can we together analyze variety of omics data, and this is a pipeline which enables us to do that kind of analysis. Then the other part is the biomarker identification for tuberculosis. Then one very important, actually our CDAC has got more than 12 centers across the country. And in the South India, we have a center at Chennai, at Thiruvananthapuram, Hyderabad, as well as Bangalore. So we have representation from all those centers today. And this Karkat Nirnay Yantra is developed in Kolkata. So this is meant for, it is IR-based screening for breast cancer. So this is an important demonstration which is available with us and also has an AI component to it. Then we talk about the indigenized system of automated screening of cervical cancer using AI and robotics. So this is developed called as ServiceScan, and recently we have done a technology transfer for this product. And this is important for the cervical cancer, and also patents have been filed for this product. The other component is related to Drishti. So this is for diabetic retinopathy and useful for identification of diabetic retinopathy, and also uses AI algorithms. So here image quality assessment is enabled, then automatic detection of retinal pathologies, disease severity scoring. So a lot of analysis can be done, and specific points have to be covered to enable that particular AI model. So different models have to be defined for different problems that we define. Then mCAD system is targeted towards mammograms. So this helps in the analysis to figure out calcifications, to figure out the masses, figure out the architectural distortions. Breast density is indicative of malignancies. We also have a product for colorectal cancer for virtual endoscopy. So these are some of the use cases which we discussed before. Then another interesting application which AI provides us is the treatment planning system, which is called as Aakanksha. And in this system, where the software has been designed to provide DICOM-related, it takes as input the radiology-related data, and also gives an output the treatment which can be given for that particular cancer. Then very important aspect is capacity building, and CDAC has conducted 3 training programs as yet, specifically for medical doctors. And we have really, it is difficult because, like we realize, unless we do hands-on work, it is, like Sir also said today morning, that we don't want to become programmers. Definitely that is not the aim. But even to define a statement which an engineer can solve requires us to understand what are the technologies that are available and which could be useful for our purpose. So with this view in mind, we have done these capacity building programs for about 120 plus medical professionals. Then looking at the Paramsiddhi AI platform, this is listed, this is the fastest supercomputer in the country today, and has the 62nd position worldwide. Paramsiddhi has entered into the production mode and has specific hardware which are called as GPUs to enable the AI workloads. So this is a very good infrastructure which we can explore using, in addition to the bioinformatics infrastructure which we had discussed yesterday. So another variant of this Param is what we call as, this earlier one is a huge elephant which resides in Pune and has to be accessed remotely. This is a smaller version of a parallel computing environment which can be deployed at the hospital or at the medical center, research center, where we want to have these kind of workloads, and it is called as Param Shavak for deep learning. And these are some of the pre-built libraries are available, and the developers or the medical professionals can together, they can start using the system immediately. So this is provided because otherwise the installation and setup itself takes a lot of time to get started. And we have seen a lot of these benefits since morning, and I would like to highlight and emphasize a few of them. So it is really not going to replace the medical doctor in any near future. We'll always require, because however much we work on the AI models, we will not go beyond 80% or 85% of accuracy. We will, and like a lot of ethical issues were raised since morning, and we had sessions on the legal aspects as well. So the final decision definitely will lie with the doctor. The another important skill which we required the doctors to have from our experience on the ioncology.ai platform is the annotation. So this annotation word itself has many variety of connotations based on what we are trying to do as a model. So we need to learn as doctors, it is a very important skill, and we have heard quite a lot about this. And there are many subtypes of annotations, so depending on our objective, we will have to do different kinds of annotations on the data. The third we discussed a couple of times before is bridging the terminology gap between the doctors and the engineers. So this platform has been interesting, and like you'll have previous speakers, we should continue this effort in the future also. And I think someone mentioned that not in India, but in outside India, we have a situation where on a lunch table, we are able to sit together and discuss a lot of things. And that also gives us many new ideas. The last one is collaboration between experts of IT as well as medicine. And even in medicine, even within radiology, there are so many departments that one doesn't know what is happening in the other department. So inter as well as intra, these are the things we need to look at. So I would like to thank everyone very much. And one message I would like to leave you with is the statement which our Prime Minister had made, that is IT plus IT is equal to IT, which means Indian talent plus information technology defines India tomorrow. And what I've added here is powered by AI. So that is an important aspect here. And I would like to leave you with this thought, and we should continue this conversation beyond these 2 days as well. Thank you so much.
Thank you, ma'am. In the interest of time, we'll take one question from the audience, if there is. Yeah, thank you.
Hi, ma'am. My name is Arnab, and I work as an engineer at Medibuddy. So first of all, I would like to thank you for pointing out that it is very important to frame a problem statement properly for an engineer like myself to understand that what exactly we are trying to build, like specifically working in healthcare. So my question to you is that you mentioned that you are using supercomputers in order to train models, right? But most of us don't have access to that, and we use cloud systems, let's say AWS or Azure or GCP, in order to train our models, and they have a pretty good performance and reliability as such, right? So in the aspect of cost as well as performance, how do supercomputers, compare to the cloud resources that we generally use?
Yes, so I would like to answer this in two parts. So one, we discussed about the data security aspect. So all these cloud systems, the data does not reside in India typically. When we upload the data for analytics, it goes to outside servers. So that is kind of not acceptable to many institutions. That is part number one. If you work on a supercomputing resource within the country, the data resides completely within our boundaries. That is number one. The number two, like you have said, that when we work on Colab kind of environments, Google Colab is one platform which is an example of the cloud-based AI model developments. So vis-a-vis those platforms, again, the amount of data that you can upload is limited, number one. Number two is the time that they give you. If the problems are small, you are able to see immediate results. But if problems are large, if you have tried building large models, then they do time sharing. So that time sharing takes a lot of time typically. So you can get started. Definitely those platforms are very good to get started with small AI problems. But when you want to move to larger and scalable problems, then you need infrastructure like the supercomputing platform.
Sorry, just one small follow-up question.
Sure.
In respect to time. Actually, the first part that you said that data centers reside outside of India, that is not true right now.
Mm-hmm.
There are huge data centers of AWS in Mumbai as well as Hyderabad as of last month,
Mm-hmm.
right? And second thing is, I did not talk about Google Colab as such. I was asking about the AWS cloud resources that we use. Okay. So their performance is as good as any supercomputers out there if we have the right amount of resources for it. Okay. So using an internal supercomputer, how does it help us with the cost or the performance as compared to AWS or any cloud provider as there, not Google Colab?
So actually, it is similar. Performance-wise, there is no difference. So you can use AWS also if your company policy permits using AWS. But typically, the government and the sectors which we want to have Atmanirbhar kind of platforms. So we want to always promote things which are made in India, developed in India, so that we develop our own technologies as well. And in times of when emergencies arise, if you have seen last year, immediately there is a retraction of services given to other nations. People always try to serve their own countries first. So as a strategy, I think it is important that we work on our own platforms as a long-term strategy, and health being a very, very critical area, I think it makes a lot of sense to think about this aspect as well.
Thank you, ma'am.
Sure, thank you so much.
Thank you very much, ma'am.